So, good morning, welcome to So You Think You Know PHPUnit. My name is Sebastian and I can help you adopt PHPUnit, optimize your tests, refine your development processes and write more testable code. I hope that these are topics that interest you for the next 45 minutes for this presentation, but I would also like to work with you and your team to help you get more out of PHPUnit. This presentation is a so-called shotgun buffet, which I think is a terrible name, but it's a name that's stuck. And this is a type of presentation where I throw topics and features at you, and somehow this is called a shotgun buffet. So I saw a presentation like this, in all seriousness now, I try to be that at least. I saw a presentation like this a while ago for a different technology, and I thought, this is interesting. These are all features of that particular tool that I never knew about, and I think I would have loved knowing about them earlier. So I thought long and hard, what could features in PHPUnit be that I, of course, know because I developed them and use them, because why would I have developed them if I did not want to use them? But a lot of people do not know about yet. So this is my attempt of changing that. So I would like to start with features related to code coverage. And this has been a topic that I've been working on, and to a really large extent, Derek has been working on for a really long time now. It was almost 20 years ago that I convinced him to implement a functionality in Xdebug to track which lines of code are executed while a program is running. And I wanted to use that in PHPUnit to implement all the features that I'm about to show you, because I want to be able to measure code coverage, report which parts of the code are executed while the tests are running, which test is responsible for a line being green, where am I missing tests, and so on and so forth. Over time, I discovered a lot of other useful things that would help with getting the most out of this metric. For instance, making your intent clear what you want to cover with a specific test. This is where in the before times, like before PHP 8 and PHPUnit 10, we used annotations, text in comments, in special comment notation, to mark the target for code coverage of a specific test. You can forget about that. These days we have attributes, and one of those attributes is covers class. So the developer of this test made it clear that they intend to cover the camera class, the code in the camera class with this test. And when we run these tests, PHPUnit gives us the feedback, hey, wait a minute, you are running these tests, and this test executes this piece of code, but that is not listed as one of your intended targets for code coverage. So something might be wrong. This is why PHPUnit reports that as a risky test, right? So there are a couple of ways of dealing with that. You can tell PHPUnit, oh, I forgot to make that clear. This test is not supposed to be a small unit test. It is more like an integration test. And then this risky test warning will go away because we are in a larger test scope and we actually intend to run more code than the one that we're interested in. You could also react to that, oh, I forgot to use a test stub or a mock object for that collaborating object that we are executing code for while we're testing the one thing that we're actually interested in. Or you could make it explicit that you expect this other piece of code to be run while the tests for camera are running, but you still do not want this test to contribute to code coverage for, in this case, the matrix class, because that is what the specific tests for the matrix class are for. need to go back. I forgot to mention there's also another attribute there, small, which makes your intent clear that you think of the tests in this test class as being unit tests. Tests that want to test a small unit of code in isolation from everything else. Now we can run our tests again and collect code coverage information, process that code coverage information, and visualize that in an HTML-based report. And this is usually the time where I have a look at the screen to test whether the screen is good, and it is good because we can see that these lines are highlighted in green. This is good, contrast is good. And if we run only the large tests, the integration tests, the end-to-end tests, not the small unit tests for this project, we see that all lines of code that we see here on this slide are marked with a green background, meaning that these lines of code are executed while these tests are running. They are highlighted in a light shade of green because they are only run, only exercised, only verified. Pick the word that resonates the most with you. They are only run by tests where you make your intention clear that these are large tests. These are not small tests. And the idea behind that is that usually you get more precise information, more reliability, more trust in a line being covered when it's covered by a smaller test, because that test focuses on what this line of code is about. It could be that we executed these lines of code while testing something completely unrelated. So far, we can only say if we run everything in the large scale, how we are using it later in production, it does not crash. We might not be explicitly verifying that this code works correctly. If we run only the small tests that cover this code, we see a darker shade of green because now small tests are responsible for this line being green. And we see that one line of code, line 116, is now no longer green. It is now red because we are missing a small unit test that is specifically tests this line of code in a small test. So this gives us some insight. And if we run all the tests, small, medium, and large, we see almost everything is dark green. Line 116 is no longer red, but it is shown in a light shade of green, showing, hey, it is covered by a test, but it's only covered by a large test. It's not yet covered by a small test. So far we only talked about lines, but line coverage is the weakest code coverage metric. Sometimes you need to drill down a bit more and see, do I cover all the different states for an if statement or a switch statement, for instance? Are all these conditionals that I use in these expressions evaluated to at least once true and at least once false by a test? And this is where branch coverage comes into play. This is what we see here. So in this example, we also have 100%. We have 100% line coverage, but we might not have 100% branch or even stronger metric, the path coverage, where we look at all the linearly independent, sorry for using mathematical terms, are all the different execution paths that we can take through this unit of code taken by at least one test. And this is usually requiring many more tests than to get to 100% line coverage. And at this point, I always need to apologize because we still do not have a really good visualization of this information. It's not Derek's fault. It's to some degree my fault because I'm unwilling to pay a lot of money to commercial vendors that only show how they visualize this. For C++ projects, if you give them money, they don't even show you how they visualize this before you buy the product. And academic research is not very helpful because they say it's really easy. Just use a graph-based representation. like all the different decision points, make that a node, and then have edges between the nodes, and color the edges green that are taken, that are covered by a test, and leave the ones red that are not taken. And then you know which paths you still need to cover, and that is true, and it works, but not in practice. It works in theory, as Derek has shown, also for the PHP world, because he has a script that does that based on information from Xdebug. But in real world units of code from an application like Drupal, for example, these graphs get so big so quickly that you do not see the forest for the trees anymore. So the only thing that PHPUnit can give you in a useful manner with regards to this metric is, in this unit of code, there are 10,000 different paths of execution possible, and you're currently only covering 9,999. And here are some hints as to which path that might be. And this is what that would look like. Not sure if you ever wanted to know or see what PHP looks like when you're executing it. So this is what this assembly of PHP bytecode would look like if you've ever done any assembly. This is very similar to that. I'm only showing you that because this information can be used to provide a graph like that, and you see the different execution points and see, okay, I might be missing a test that looks like this, that touches these edges. But that is not very practical in everyday life, and I'll come back to that at the end of the presentation, because there's something that is complementary to that, and in almost all cases that are relevant in the real world, good enough. I want to show you a couple of things related to selecting the tests that you are running. PHPUnit allows you or gives you many different ways of organizing your test suite. That does not mean that one way is better than the other. They are complementary. So one typical way that almost everyone has seen at least once is just using the directory structure of the tests directory, and have top-level directories under the test directory for tests that you think of as unit tests or integration tests or end-to-end tests, and then reflect, for instance, under the unit directory, the directory structure, the project structure of the production code, and have a one-to-one relationship between test case class and production code class. And in your PHPUnit XML configuration file, you can make that intent clear and tell PHPUnit about that and say, hey, I have two different test suites that I want to be able to reference by name. And you want to have one test suite that is named unit, one test suite that is named integration, and you find the tests for that in those directories. And the bootstrap attribute that you can see there, that is a rather new feature. I think that is now 2 or 3 months old. Came in one of the earlier releases this year. That is something that has been requested for quite some time. So I'm very happy that it is finally there. It's test suite specific bootstrapping. So if you run all the tests, all 3 reference bootstrap scripts will be loaded and executed. If you only want to run the unit tests, then only the top-level bootstrap script and the bootstrap script for the unit test suite will be loaded, but not the one for integration tests. So you do not do too much work while only wanting to run the unit tests. So that's quite good. There are some CLI options for the test runner that use this information. So for instance, there is list suites that gives you, as the name suggests, a list of the suites that you have in your project. So in this case, we get the information there is a test suite named integration that has 5 tests, and a test suite that is named unit that has 172 tests. You can use the --test suite CLI option to only run the tests from a list of suites. So in this case, we only run the tests from the test suite unit. All other tests are filtered out, are excluded. You can do it the other way around. you can say, hey, please run all the tests except for the ones that are in the unit suite. And in our example, of course, that would be equivalent to saying dash dash test suite integration. But you might not know that. You may have more than just 2 test suites configured, and this allows you to be very flexible and very specific. I only want to run those tests. In addition, and complementary to test suite level organization using the file system structure, you can use the group attribute to put individual tests or all tests of a test case class into specific groups. So for instance, in this example project, we have groups that are named canvas, intersection, material, math, and shape. And in addition to that, we have groups that are filled from the small, medium, large attribute that are very specific, because we have some very specific semantic to what do we think, how do we think about this test? Is this a small unit test? Is this a large-scale end-to-end test, and so on? And of course, we can also filter using using the groups. We can say dash dash group, small, and we run only the small test. We can say exclude group and run all the tests that are not small. And in practice, you will have groups like database, and you tag all your tests that touch the database with that. Or more generally speaking, I/O. You may want to have a group that makes it clear these are tests that need I/O, that need to talk to the outside world. Or if you want to use something that is less technical, just call those tests slow. Yeah? And that allows you really conveniently to tell PHPUnit, please run all the tests that are not slow. Because I'm currently working on something, and for what I'm currently doing, I only want the fast tests, and the slow tests I either run manually later before I commit and push, or I leave the running of the slow tests exclusively to my CI pipeline and get feedback 10-15 minutes later after I pushed, hey, what you just pushed, that broke the build, there's one of those slow tests that you did not bother to run, failed, hey, fix that. There is the CLI option list tests, which lists all the tests that would be run. And this can be helpful in identifying whether or not the filtering that you wanted actually works, or to get an idea of how PHPUnit represents with an ID internally your tests. And there are additional CLI options like --filter that operate on this ID to very specifically select maybe just one test to be run. It's important to know that --filter uses substring matching, so you can use the name of a class, for instance, or the name of a test method, or if you want to be very specific, name of the class, _, test method, and then only that one test method will be run. I'm skipping on special syntax for --filter, because --filter also supports regular expressions, if that is your kind of thing. And there's also special notation, like if you're using testless data providers, you can say, okay, please only run it with the 5th data set that this data provider that are using tests uses. Yeah, this would run all the tests from the camera test class. This would run all the tests that have test constructing a camera in their name. I think you get the idea. There's another thing that is quite interesting, and I use that regularly when I'm working on some part of my system, and I know other parts of the system directly depend on that. So you can reuse or use in a different context the information from the covers and uses attributes that I've shown you earlier to filter. So this would run all the tests that cover the camera class, regardless of whether they are the small tests or integration tests or large tests. This, I think, is even more interesting. This runs all the tests that use a specific class. So I do not my feedback loop or my test loop, if you will, sometimes looks like this. I'm working on this one class. I run every couple of seconds the tests for that one class while I'm working on it. At some point, I'm confident that I implemented what I wanted to make the change that I wanted to make, and that it's correct. Now I expand the testing and to run the tests for everything that uses the thing that I currently changed. And if that still works, in most cases, I'm confident enough to commit and push that and leave the rest to this unit. Showed you earlier this the list tests CNI option, which hopefully gives human readable output, but you'll be the judge of that. At least I can read that. But just because I can read that does not mean that every other human can read that. Sometimes you need the same information in a machine-readable format, and that's what list tests XML does. This gives you a huge XML document with a list of all the tests that would be run, and that makes it maybe not convenient and nice, but at least it makes it possible and a lot simpler than what you would have to do if this did not exist, to write additional tooling around PHPUnit to then, okay, I can now write a script that takes this as input and splits it in 10 smaller XML files, and then I write a raw small script wrapper around PHPUnit to run only the tests that are listed in the XML file, and suddenly you have something that allows you to do parallel and distributed test execution. I wouldn't use an approach like that for parallel test execution because there are special solutions, extensions for and wrappers around PHPUnit that do that out of the box without you having to do anything special. Paratest, ParaUnit come to mind, but there is no ready-made solution that distributes running the test across multiple nodes in a network. For instance, if you have millions of tests, even parallel test execution fails at some point to improve test execution speed, and then you need to look into distributed running, and that's when this becomes helpful. I would like to talk about outputs. So, some people do not like to see the progress output. Yeah, by default, PHPUnit prints a single character for each test that was run, using a character that indicates how executing that test went. If it was successful, it's a dot. If there was an assertion failure, it's an F. If there was an unexpected error, it's an E. If the test was successful, but PHPUnit thinks that there was something odd about the test, it's an R for risky. If you trigger the deprecation, either in PHP or in PHPUnit or in one of your third-party vendor dependencies, then you would get a D for deprecation and so on. We also have W for warnings and N for notices, and I'm pretty sure at some point we will use all 26 letters of the alphabet. And then we will switch to emojis or whatever, I don't know. But some people do not want to see that progress output, and starting with PHPUnit 10, that is finally, at least if you ask them, possible by using -- no progress. Some people do not want to see the results.
Why?
So I did not bother asking the question why you do not want to see the results, at least not initially. It was a really simple change to make, so I said, okay, some people asked about it, so I cannot foresee any negative impact for the rest of the code base if I implement that, so I just implemented that. Some people do not want to see any output at all. So there is no output. I mean, there are forks of PHPUnit that remove the PHPUnit version number by Sebastian Bergmann and contributors because they do not want to see my name all the time. So maybe that makes them happy, I don't know. So the serious answer that I got a couple of times when I asked why do you not want to see the output is because our output is so huge that we frequently run out of disk space in our CI server. And I got that multiple times from different teams. So I don't know, suppressing the output is the right approach to that, but if it is a CI/CD pipeline, as they claim, all you care about is the shell exit code because that makes the difference between red or green for the build, and they were happy with that. But I, as a developer working in such a team, would be very frustrated if CI tells me, using a Slack bot or an email that I get or whatever notification mechanism that the team uses, hey, you broke the build, and then I go to the CI server and I do not see any details because there is no output. That does not make sense to me, but I try to implement what makes people happy. Sometimes that's sensible, sometimes it's not. Talking about things that I find very sensitive and useful, or sensible and useful, that is the test box output. This is a feature that I first came across 20 plus years ago with a really niche extension for JUnit called JUnitor. And the idea that the authors of that extension had was, hey, we can take the name of the test method, strip away the test prefix, and insert a space wherever there's a separation in camel case, uppercase, lowercase, just insert a space. And if you put some effort into naming your tests properly, like they tell in one sentence a part of the story what the thing that you're testing is about, then you get readable human sentences that tell you how does this software work, what can it do, what can it not do, and so on. And to me, testing is so much more than just having automated code that verifies that my code works correctly. It's also about specifying what the software should do, especially when you do test-driven development and write the tests first, or documentation, documenting through code how the code works, how the concepts from your domain are reflected in code, what works, what doesn't work. I think that there's a lot of value in that. And over the years, this feature has been expanded quite a bit. So for instance, you may be wondering by now, wait a minute, Sebastian just told us, PHPUnit just takes the method name, strips the test prefix, and inserts the space according to camel case or snake case. Then how is it possible that we see something like w equals 1.0 because you cannot use that in a method name? You also cannot use braces in your method name, so where's that coming from? So over the years, we added some features to that. So this is the really simple case. This is how it all started. We have a test method name, test the vector can be added to a point, and then if you use test docs output, you get that check mark, a vector can be added to a point. And to reiterate, the idea behind this acts as executable documentation, executable specification. When a new team member comes to work on this project, they can run the tests when they need to work on Drupal or Camera or whatever for the very first time, look at the test docs output, see what this is about, and they usually see one of those tests that resonates with them, making it clear, oh, this is related to what my task is currently. So they can look into the test code behind that one line of output in the test docs output and get an example that they can copy paste that and start the development from. And they can be sure that this is correct code because this is test code. This is verified by running it. It's guaranteed to be correct. So the first thing that we did at some point was introduce metadata to be more specific about what this test method is about, especially in a situation where we need to use characters that we cannot use in a method name. So this is where the W equals 1.0 comes from. Then at some point, data providers became not only a feature, they were a feature early on, but it took a couple of time or quite some time for people to catch up to the idea of, hey, it's a good idea to separate my test code from my test data. So data providers became more commonly used, and then at some point, oh, I have a data provider that provides 10,000 data sets to run the test 10,000 times. Suddenly my test docs output does not look so nice as it used to. So that's when we expanded the test docs attribute to use or to support placeholders. So you can use the names of the parameters that go into your test method coming from a data provider and customize a string that you see at the bottom. For example, the magnitude of vector 100 is calculated to be 1. And until very recently, until like 3-4 months ago, I thought this is sufficient. I will never ever have to touch this again. And then I was doing I was giving a test-driven development training, and both my attendees and I at some point said, okay, this test docs output is not as good as it could be, but we're using a data provider here, and we have reached the limitations of what I thought would be sufficient. And then collaboratively, we had the idea of, okay, let's go one step further and introduce a callback that takes the values for this test from the data provider and allows us to fully customize the message. So in this case, we can take a datetime immutable object and format that however we want to format it for the particular test that we are currently writing. So we get highly customized test box output, even for tests and data providers like that. Final thing about output, the debug output. This is definitely not something that you want to use every day, but you will be very thankful that it exists when you are in a situation where you need it. And when might you need it? You have hundreds of thousands of tests, and you run them, and suddenly in the middle it crashes. PHP crashes, or you run into some error that is so bizarre and obscure that it completely crashes PHPUnit, and PHPUnit cannot tell you what happened. And this is where debug comes into play, because under the hood of PHPUnit, everything is an event since PHPUnit 10. For everything that PHPUnit does, an event is emitted, and all the output that I've shown you and all the log files that PHPUnit can create are based on these events. We just transform the event stream into a JUnit XML log file, into an open test reporting log file, or whatever, or in the text output on the console that you see. Debug visualizes every event that has happened since you started PHPUnit. And when PHP crashes in a test, somewhere in the middle of your test suite, and you use the debug option, the last event that you will see will be test prepared, because PHPUnit has finished preparing that test, and the next thing that PHPUnit does after that event has been emitted is to execute your test method. And there is your crash. And of course, the same holds true if PHP crashes in your setup method, or in your teardown method, or in your data provider. And if you need more details, you can get telemetry information, meaning how much time has passed between two events, how much memory was used between those two events. And you'll always, like, when it comes to the time information, there are two values: time since you started PHPUnit, which is cumulative, and time since the previous event. So if you have a feeling that you may have a test somewhere that is taking unusually long, this would be one way of drilling down, okay, is it taking long in its setup method or in the actual test method, or what is going on? And of course, since we have the event system, you can write a small extension, if you will, to subscribe to the events that you're interested in, and write your own visualization that helps you. Yeah. Okay. I sometimes joke that I'm a guy with issues, but luckily most of my issues are on GitHub. But there are some types of issues, and deprecations are one of them, that you at some point need to deal with. So let's assume you have code like this. This is first-party code. This is code that you wrote, that you are responsible for. And it uses third-party code that is in your vendor directory, for instance. And then we have first-party code again, but this time it's your test for your code. And if you run your tests, you can configure PHPUnit to treat deprecations in these different areas of code, first-party code, your code, third-party code, vendor dependencies, differently when it comes to deprecations, for example, because only you can do something about deprecations in your code, and you want to deal with them as soon as possible, if you ask me. But you cannot really do much about deprecations in your vendor directory unless you start contributing upstream and opening tickets and sending pull requests and so on. But until then, until that gets merged and you get the new version, you cannot do anything about that. So most teams opt into, hey, PHPUnit, please do not report deprecations in code that I use. Only report deprecations in my code, and that is the configuration for that. So if you run PHPUnit then and pass the display deprecations CLI options, this is what you would see. Big improvement since PHP over PHPUnit 9, introduced with PHPUnit 10 and refined in 11 and 12, is the output. Before, you would see every triggering of a deprecation. Like if you have a trigger deprecation in a loop and you execute the loop 10,000 times, you would see 10,000 deprecations, which is not useful. So now you see each deprecation only once with information how often was this triggered. And that makes it really easy to drill down, okay, I need to address this, how do I address this? Another way of dealing with it is put your hand into the sand and don't look at it. That's one way of looking at this. I don't recommend doing that, but PHPUnit, just like PHPStan, for example, offers a feature called baseline. So you can run your tests, create a baseline, and tell PHPUnit, hey, please, from now on, only report deprecations that are new, that are not yet on the baseline, and eventually I get to the baseline. Usually the eventually never happens, but if used properly, this can happen. Okay. So use the baseline, and then you see one issue was ignored by the baseline. Best practices, best practice configuration. Please do yourself a favor and configure PHP accordingly for development when you use PHPUnit. I kid you not, I get reports all the time, oh, PHPUnit is broken. I run my tests and there is an error somewhere, and PHPUnit does not display that. If you configure your PHP to ignore all errors and never ever display errors, I cannot do anything about that. Well, I could, but I don't want to, because that would be obscure, because suddenly PHPUnit would, without telling you, change configuration, and that would be not good. So there is --check PHP configuration that you can use, and it tells you, hey, is my PHP configured according to best practices? And if it's not, then you can look at the PHPUnit documentation, which explains for each of these settings which the recommended setting is and why it is that recommended setting for that. You can use PHPUnit -- generate configuration to create a PHPUnit XML configuration file with best practice defaults. And this looks like that. It basically just configures the cache directory for PHPUnit to a common location. It configures a good execution order, so it first runs tests that depend on other tests. It resolves the dependencies, and then after that sorting, it runs tests first that failed the last time you ran the tests. So you get quick feedback on what you're currently working on. And then some things like, okay, I want to be very strict. Some people say I want to be very German about certain things related to metadata and code coverage and handling of risky tests and warnings. And it configures how you want to deal with deprecations. Report deprecations in my code, as I explained earlier, ignore deprecations in third-party code. There's an entire ecosystem around PHPUnit. So for instance, this is an example of an extension for PHPUnit that does something useful. It's called Slow Test Detector, and from the name you can probably guess what it does. And this shows how easy it is to install or configure such an extension. You put it somewhere where Composer autoloading, for instance, can find it, and then just say here, okay, I want to use this extension. You need to configure the bootstrap, which is the entry point into that extension. This is a class that implements a certain interface from PHPUnit, and PHPUnit will run that to initialize and register the extension. And then some extensions like this one have configuration parameters like, okay, I only want to see the 3 slowest tests, and everything that takes longer than 250 milliseconds is what I consider slow in this configuration, and that is how you can configure that. And then you can run your tests, for example, and get additional output. We're talking about output again. And an extension can say, I want to completely replace the default output, which automatically tells PHPUnit to behave in exactly the same way as I showed earlier with -- no output, and then all output must come from the extension. And please do not open a ticket for PHPUnit. When you install an extension that replaces the output and then something in the output is wrong. That's not one of the issues that I am responsible for. It's sometimes a bit confusing. Yes, there's infection, which is really interesting. Builds or implements an idea from the early 1970s to deterministically introduce bugs into your code and run your tests again, and if the tests still pass, then the mutant escaped, the mutant was not killed, which is what happens when a test starts failing. And this is a really, really, really good way of testing your tests and finding things that you only think are tested because they're covered, they are marked as green in the HTML code coverage report. That really helps, and to me, in most situations, has the same effect as path coverage, which I talked about earlier. So path coverage is mathematically correct to give you, structurally, you tested everything that you can possibly test here, which might require a gigantic amount of tests to reach that. Mutation testing is a much more pragmatic approach, and it's much faster to execute. Because that's the biggest problem with path coverage. It makes your test execution really, really, really slow. And I really do not mean that as a negative feedback towards Derek, who implemented that. I know that it cannot really be implemented in a much faster way. There are some performance improvements that he's working on, but if you look at similar tools for different language stacks, they all have a massive drop in performance when you do that. already 15 seconds over time. I try really hard to only go over by 1 minute. So there is Paratest, which is an easy solution for the problem. I have so many tests. I could really ban it, and that's the most important thing, and a lot of my tests are very slow. Then you can get a lot of benefit without much effort by just installing Paratest, and Paratest runs your tests in parallel. There's PEST-PHP, which is both an extension for and a wrapper around PHPUnit. You do not really see that you're using PHPUnit when you're using PEST, but it allows you to write your tests using a different syntax that is more appealing to some people, and it gives you output that is more appealing to some people. I'm fine with that. I just don't use it because I want to write my test and see my output in the way that I implemented in PHPUnit. This presentation has a home on the web where you can download the material, and you can also find an article there that highlights the most important features that I would like you to take away from today's presentation. And last but not least, sorry, I broke the promise of running only 1 minute over. I would like to learn from you. I would like to learn from the Drupal community how you work in your projects. What do your development processes look like? What do your deployment processes look like? How do you use PHPUnit if you already use it? Are there frequent obstacles, common obstacles that you can run into? Is there something that PHPUnit could help you with to make your life easier? Be it you're working on Drupal core, being you're working on Drupal extensions, being you're using Drupal to build solutions for your clients. I would really like to hear from you because I think we can learn from each other. And for that, I'm offering you a free 2-hour Zoom session in November where we can just share our expertise and experience and learn from each other. And I really look forward to that, and would love to see a lot of people there because I honestly believe we can learn a lot from each other. And with that, I'm finally done. Thank you. Do we have questions?
Yeah, I think the debug output, it prints every assertion values, right? Does it?
Not anymore.
Okay.
So in PHPUnit 10, we were so excited with the new event system that we emitted events that we thought might be useful, but we did not have a use case for them. And we did not need them ourselves to create the output from PHPUnit. So we also emitted an event for each assertion that was performed. And this caused a huge performance and memory problem because some people apparently put megabytes of data into what they assert.
Which is not wrong. Sometimes you need to do it.
Yeah, in some cases you need to do it, yes. But I was surprised that so many did that. And we need to export that, all those values that are passed to the event system, so people do not do looking for the right adjective that does not sound negative. Thank you, interest. That do interesting things with the event, because with the previous extension mechanism for PHPUnit, people were able to do things like the Volkswagen extension. Like an extension that you install into PHPUnit and it detects whether your tests are running locally on your machine or in the CI/CD pipeline. You get honest results when you run them locally. And all the tests pass all the time, leading to 100% code coverage when you run it in your CI pipeline. And that one of my motivations for the new for implementation details of the new event system is to prevent that from happening.
Okay.
But
yeah.
Your question, sorry.
Yeah, so the question was, because in I think PHP 9 we had that the name of each test method was printed, and that was very useful in a CI or anywhere, like to see which are the tests that are currently running, where is it currently stuck. And so it's this test start, this test end, this test start, this end. And then this, I think this, at the time that was a debug parameter, and then later it got a different meaning. And I opened that issue, and then we said, no, we still have debug, it's fine. But the new debug, at least in the version that is currently used in 2.11, is not really useful because we have these big values that we assert, and so all the auto there is just too much. So it would be really nice to have like this nice, because the dots, in first and CI, sometimes the CI only reports when the dots are full, and then also it doesn't tell you which test has run or not run. And,
So two-part answer to that. PHPUnit 11 and PHPUnit 12 no longer have events for the assertions, so that part of the problem is gone. I'm open to the idea of filtering events that are shown. So I would like to, for --debug to remain as it is, but add an additional parameter that says, okay, print me the event log as it is happening, but only print the test finished event or something like that.
Yeah, that would be nice. Yeah. And for the test, for the test docs, it prints like a human readable way. But for me, it's better to just have the raw method name because then it's searchable.